Man, nobody watches these.
I know, no one sees it.
I can't remember my username.
What we should do
I'm
is
sending it to you
have
tonight.
like a compilation of intros, and like make everyone a DVD for a going away present. Here.
It's just like some Chris jumping in and then
Get 'em
End of the semester, we're breaking the band up, you guys. It's so sad.
No, yeah, so Christmas presents.
breaking
Yeah.
the band up.
Because we're not gonna have this cute little first hour anymore.
Who's in the band?
I'm still in first hour.
Are you?
We're a
What are
family.
you still having next semester?
I think I
We are.
tried.
Hey, you got Hamburg. He was going to Bauer.
Anyway, we ruined that intro with talking.
That's why we're doing a compilation.
The shapes of the molecules, obviously we've been drawing them in 2 dimensions on the board and on your paper, but in reality all the molecules, all the covalent molecules exist as 3-dimensional shapes. And so we're going to take a look at some of those shapes today. And then as I mentioned on Monday, kind of come back and look at the models and actually get a sense of what the real shapes are in 3 dimensions. And so today will be kind of abstract. If you're not good at visualizing complicated 3-dimensional shapes, then you might have some difficulty, but they're not too difficult. The 3-dimensional molecules, important in determining the molecule's physical and chemical properties. We're going to kind of come back to that on Monday and talk about the properties of those shapes later. But for now, just kind of identify the shapes and look at the different shapes, and that's really all the goal of today is. So, you can predict the shape of the molecule by its Lewis structure. So there's no real new, like drawing a Lewis structure. You should already, have a vague idea how to do that. And then that structure should tell you what the 3-dimensional shape is. The shape itself is governed by something called VSEPR theory, valence shell electron pair propulsion theory. Electrons do not like each other, and you can imagine the atom as a ball, okay? And the electrons want to be as far away from each other on that 3D sphere as possible. So if there's 2 sets of electrons, they're going to be on opposite sides of this sphere. If there's 3 electrons, they're going to be on. Well, you'll see. They want to be as far away from each other as possible. They want to have the lowest possible energy. And so VSEPR theory determines those shapes. It's basically the idea that pairs of electrons surrounding each other, or surrounding an atom, tend to repel each other. They don't have to be next to one another. They want to be far apart. Yes, sir.
If electrons don't like each other, then why do they try to have 8 valence electrons? Why do they try to get more?
Well, 8 is the full shell. So they don't like to be next to one another. They have to be. They have, but that position, being next to each other is uncomfortable for them. But having 8 is a full shell, and that is happy. Like Thanksgiving dinner, happy. You're gonna hate yourself if you eat one more, turkey leg, but you might have to do it.
But you eat 8 and you feel good.
So you're eating 8 turkey legs and you're good.
If you gain
You're
8
disgusting, but
pounds.
you're good. So VSEPR, although it looks like the CPR, I'm going to call it VSEPR theory. The shape of the molecule is determined by the central atom. That's all that you're looking at when you determine the shape of the atom. You don't care about anything else. I would make sure that you highlight the central atom or put some underline or something like that. The central atom is what governs the shape of the entire molecule. We're going to look at the most kind of basic shapes. There's a hand, tetrahedral is one. The shared pairs that form different bonds repel each other remain as far apart as possible. So the idea is that you have a certain amount of things on, let's say, this little tiny globe. Okay? If you imagine the atom as a globe, and you want to put all those things as far apart in the globe as possible. That's the bottom line. And there's a handful of ways to do that.
Is that it? Is that it?
Oh, well, that's it. Well, I have some things to say, but that's it for the note taking.
Good.
The table.
Oh,
wait. Oh, sorry. I'm sorry.
I'm making a noise. What? Why you mean?
Very good. It's fun to me, man. You know some.
We're good?
Yeah.
Okay. Did you close up on the drinking water?
No.
It's so obvious, so Mark is back there laughing. Okay, what does it say? Okay, so if we take a look at an example, this is carbon dioxide. Drawing this, you should know how to do. And you look at the atom itself, and there's a table below this, which we'll get to in a second, but essentially, when you determine shape, all you care about is this. Okay? All you care about is the central atom. You don't care what is going on. You just say how many things are bound to the central atom. That's it. And not how many bonds, because these are double bonds, so you'd say it's got 4 bonds, but instead you say how many things. That's it. So it's got 2 atoms on it, right? It's got no unshared pairs. And then you just consult the table and say, okay, what kind of shape is that? And you can clearly see that there's only one. I mean, this is drawn in a line, so it's going to be a linear shape. But if you scroll down the table, which is down here somewhere. Hold on. So here's the table. These are the shapes that I expect that you'll know. You look at the central atom, and you say number of bonding groups, and so that's how many things are bonded to it, not bonds, but things. So if it's a double bond counts as one thing. And then how many lone pairs or unshared pairs does it have? And then that tells you the geometry. The geometries that we care about in this class are going to be linear, trigonal planar, which is a triangle plane, like a B-2 bomber, a triangle on the same plane. A bent configuration, which is what it sounds like this. Tetrahedral, which is sort of like a jack almost, if you play jacks. Who hasn't played jacks recently? Trigonal pyramidal, which is a triangle pyramid, like you think it is. And then trigonal bipyramidal we might get to, probably not. 2 pyramids stacked end to
Go to the
end.
link.
Should I?
Do it.
Click
Well, I have all the pictures on them. I'm going to show you that right now.
What's that? What's that?
Where did that go?
Reading.
So here are some of the shapes. This is linear. And it's got, this is the carbon dioxide one that we have. So this is, you would consider these double bonds. This is an oxygen, that's an oxygen, this is the carbon in the middle. There's no unshared pairs of electrons. And so the whole thing, the way that, it wants this oxygen and this oxygen to be as far apart from each other as possible. So the only way to do that is put them on exact opposite sides of each other. And so that's how you get the linear shape. You go next. Can't go next.
Let's do it.
For trigonal planar, all 3 are on the same plane. Whoopsies. Which is hard to tell here, but you'll tell on Monday. So this will be, let's see, what we call this. Maybe the one that we just looked at was carbonate. So CO3 with a -2 charge. Here's one of these is a double bond, which again you'll tell later. But all 4 things are on the same plane. That's called a trigonal planar. I don't want to really waste time showing you all of these, but the interesting one's the bent one here. This is one that's kind of important, which we'll look at later. This could be water.
Why is it bent like that?
And the reason it's bent like that is because you can't see it here, but there's a pair of electrons here, and there's a pair of electrons here. And essentially they want to be far apart from each other, so they actually bend the molecule so that it can be as far apart from one another as possible.
Malaria's here.
No, but it was too hard to pass. I'm sorry, Malalia. There's no harm intended.
Alright.
It's just something that's funny. And then, let's see.
Pyramidal.
Tetrahedral is the interesting one. Tetrahedral is really common for carbon-containing compounds. So, like methane, CH4, this would be your carbon in the middle. And then this one was kind of pointing out at you, going back. This is on the same plane, and then going up. Tetrahedral. You'll build these on Monday, so don't worry about what the actual shapes are today.
T-shape.
These are ones that we're not going to worry about clearly because they get too complicated.
Why are they yellow?
They're different molecules. This is probably.
Can you show us like a super complicated one?
Sure. What's the most complicated one here? This one.
Whoa.
Pentagonal bipyramidal. Everyone's favorite.
Okay.
Go.
That's with iodine,
A fluoride.
IF7.
hepta.
You know what's the problem with IF7? What's the problem with that? That we don't know about in here. How many things How many things did you attach to your, let's say, iodine?
Oh,
7.
there's 2, there's like more than 4.
Yeah, you'd say 4, right? Would be the most things, but this one's got 7. We're not going to learn about like where you can put more things on there. That's what when you get to the d orbitals, you can put more stuff on there, and it gets kind of crazy. Like IF7.
I'll get to the F.
No.
Look at them fancy.
Or fantastic.
Okay. You want to try to wait? What happened? kind of showed you all the important ones.
You said fun question mark, that was good.
Well, we're not going to have one. The question mark is for the answer, and the answer is no.
Oh.
You tricked us.
I think I already showed you these, but the way that you identify them, do you have your little chart out? If you draw the picture, and then you look at the central atom, and then you say how many things are bonded to it. So in this particular picture, this is the central atom. How many things are bonded to it? Three things. 1, 2, and 3. This doesn't count as 2, just count it as 1. How many unshared pairs does it have?
2.
No, only the central atom. How many unshared pairs?
0.
0, okay? So then you go to your little chart right there, and you look for 3 things bonded to it, 0 unshared pairs, and tell me the shape.
Trigonal.
Trigonal, planar, means triangle plane. They're all on the same plane. They make a triangle. So this shape, the way that I drew it, is actually not really what's going on. And I don't really so much care if you draw it the correct way, but this shape is really going to be more like this, since it makes the triangle. I'm not going to draw the dots, but that's kind of the more the shape we're looking for. Triangle plane, so I make the triangle there. All on the same plane. Again, you'll get, when you start to see them on Monday, you'll figure that out.
Oh, that one's a triangle.
Triangle plane, they're all the same. You want to draw more and get us a shape? So if I drew water, which is this, typically if you were drawing it yesterday, you'd probably draw it this way. But tell me what shape that should really be. Look on your chart. How many things are bonded to that water?
Bent.
Yeah, it should be bent, right? It's got 2
So
things
should it be,
bonded.
like, up
It's
here?
got 2 unshared pairs. So what really happens is that the water molecule sort of looks like this. And the unshared pairs, which are really, well, we draw them as little dots, but they're really giant clouds of electrons, like this, and like that. They actually, they're so big, they take up so much space, and they hate each other so much, they actually bend the molecule so that they can be as far apart from one another as possible. So this part is the bent configuration.
You have to draw it like that.
I might ask you to draw it like that eventually. Today, I'm not really going to do that much.
Draw-
I do. The only thing I want you to do today is be able.
Like in backside, we'll have to draw it with a bend, or like what a bend?
Well, the only thing I care about today that you do is be able to name it or be able to identify its shape. If you want to start drawing them the right way, that's great. But some of them you can't draw the right way. Some of them are 3-dimensional that are hard to draw the right way. But something that's linear or bent or trigonal planar, those are the ones that are probably easiest to draw the right way. But if I ask you to draw like methane, which would have like 1 carbon going, or 1 hydrogen going up, 1 sort of going back this way, it's kind of difficult to draw. There's ways to do it, but we're not going to learn it.
Yeah, not really.
Oh, yeah, yeah.
Friday, you're not supposed to actually.
I know, but I am, right? And we're done.